Hey guys, it's Corey again. Today I'm continuing on through Prerak Garg's presentation from Imagine AI 2024. And today we're going through the future of work. This is one piece that is very interesting to me, coming from a development background. So I'll just go through the first part of this thing and call it good for today, but it's something to think about and something to look at so we can look at these things in pieces. So, future of work, here he is.
So what it means for the future of work. I want to talk about GitHub Copilot. For people who don't know about GitHub, it's a software repository where software developers store their code. They built an AI software called GitHub Copilot. It helps software developers write.
Okay, so I personally use GitHub and have used various repositories. The repository is more than just a repository. It's not just a place to put the code, but it also keeps track of changes. And that is super, super important. I was working on a team that we probably had, somewhere around 100 people on it at, different sites, different time zones, different everything, different cultures, languages. And we were all working on the same project. The whole group was overall. So what it does is it keeps track of the changes that occur, so that what would happen is every night we would check in our code. They would check it out in over in Asia. They'd check the code out and get the changes. Then they'd walk through the changes and implement those. Put those They just basically have to approve them into their code. They get to see if it's in the same kind of area that they've been working or are working. And if it isn't, then they just kind of let that thing, kind of import and put all the changes in. But another thing that happens is when you check this code in, when you go to, once you've decided, okay, I'm done for the day, I've tested it, I'm going to check it in. You can check it in a couple of ways. One is just check it in on your private branch. And that is, you kind of, work on a section and you are going to be off of what we call trunk for a long time. And then you would check your private branch in. So you would just be checking your code in daily to your own branch. The other one is where you want to check in basically onto trunk, or you want to put your changes and promote your changes to trunk. So that particular case, you would then when you check your code in, it doesn't really get checked in at that time. It would then run what we call before check-in script, and it would go through your code, compile it all, and then it would distribute it on multiple different devices that were very similar but different from each other to test to see if you broke anything. And the output of these tests, a series of tests on a bunch of different systems, would be compared. So there's a really complex process wrapped around this thing, but the piece that he's kind of talking about is, the developers would, modify, or this is more about just the portion of writing the code. But the GitHub typically, the Git was the repository would do a whole bunch of other things in the midst of that. So a piece of AI knowing more about the code could possibly help you do better code if it knew other changes that were in there. Otherwise, it's just a huge research project to go figure it out as you check it in with other people checking stuff in from all over the world. So this could be a huge improvement. Anyway, let's see what he has to say.
Code. So think of it like an AI programmer, pair programmer. It can help you writing full blocks of code. It can also give you autocomplete suggestions. And the software developers who are using GitHub Copilot, they have seen massive productivity gains. Almost 46% of the code is now generated by AI. And the developers using GitHub Copilot, they are 55% faster at generating code, and 75% of them are more fulfilled in their job. And it's not only software development.
Okay, we'll stop there today. Tomorrow we'll go over the other one. I've already covered this a little bit about just general knowledge workers, and these are knowledge workers too. So 46% of new code is written by AI. That's impressive. I know a lot of people are like, oh, you can just sit down and AI will just go write your code. You just kind of speak it into existence. Well, that's not very likely. But I could see it being a huge help for a developer. I know I spent tons and tons of time reformatting things, fixing, just fixing things that somehow got screwed up or they were new to the code, importing them from one chunk of code into another chunk. Matching the coding standards so that it's readable by a human. So you can go through and read this thing and it looks consistent. The coding standards are, where you place these curly braces, how you, like this header, how it's defined. You've got header colon, curly brace, and then this data, and then another curly brace and a comma. So this looks, just a kind of general structure and it's an object, but inside a function with JSON. That's quite a little bit here going on. Anyhow, the coding standard, putting in comments so that it's understood what the intent of the code was, those kinds of things. You could spend tons and tons and tons of time doing that, reformatting and fixing code, where this probably just intuitively formats it well and could even write chunks of code for you. So it's 46% is written by AI. That is a huge amount in the short period of time. And of course, 55% overall faster development. That is going to rocket projects, absolutely rocket them. And the thing that's really not shown here is, if they're faster, what do they measure? How are they measuring that? Like faster at just getting some code out, or code that actually works and tests well and actually, hits the target. I know people are concerned. Oh, they're going to replace all the software engineers on the planet, and they're going to, people just run around and be able to speak at the computers, and they'll just go write the code. There is some of that for sure. But the low level, really tightly, resource constrained or whatever, those types of things to make your code really smooth and tight and clean is going to be tough. But I think AI could probably do a pretty good job with optimization. But the big thing is going to be gathering requirements and turning those into code, translating that. Anyhow, it's like, we junked out a bunch of code, but how close was it to the target? That's one of the questions I have with this. How well did we actually meet the requirement of the code, and how well did the code actually perform in the 55% faster realm? But still, it's going to be unbelievable, absolutely unbelievable what's going to happen in the coming future. We are going to very much change the way that we write code. Now, yesterday I went through this right here, and I definitely did a lot of hardware design, and I did a lot of, in some cases, I coded stuff with switches, believe it or not, and did it with punch cards and so forth. And machine language was the next level up. I did quite a little bit in assembly language, and the next step was to jump up to C, where I was, able to do this hello world versus that level versus this kind, where you're, moving 4 into this register, moving 1 into that register, into part A and part B of the register, etc. It's just amazing the amount of the more efficient, the amount of code I could write here, because really I was trying to get an intent. If I needed to go back in and tweak it, I ended up with little chunks of assembly language throughout my project where it was super, super structured and required that kind of speed and efficiency. A lot of times there's a lot of memory required if you start doing high level languages, especially, start jumping into some of these things. It really gets, even like Python, you can create a lot of code bloat, so to speak, with those things. But I was really stuck going from here to these two levels, and it was quite an efficiency gain when we jumped from here to here. From assembly language, and I started writing stuff in C. I really was able to get out a lot more functionality in a much shorter period of time. So, and then troubleshooting things was a lot easier because assembly language can be very, very, very difficult to troubleshoot. So I think the same thing's going to happen in, this jump here. And I definitely encourage people to jump on the bandwagon and try to realize what needs to be done at this level or any of these levels down here, and what you can really leverage there. So the way I'm leveraging this now is, full on up in this level of the strategy, completely disconnected from all these other layers here. And that's, how we program the agents in Air, for instance. So in a lot of the AI tools are programmed in a much more natural language fashion. So, yeah, for sure, that's how we're programming these clients, agents in Air and in flowcharts. It's actually being done now with the Air 2.0 flowchart agent programming, if you will. So, anyhow, yeah, the future of work, it is getting crazy out there, but I think they're going to be really good changes. So, get us out of some of the details. Thanks for watching.